Okay.
And yeah.
These are problems that you can probably verbalize to me. So let's begin.
Also had a homework question.
Mm-hmm.
And yeah, I don't know if you want to start out with the homework question or if you want to start out with the test.
You know, I'm going to let you direct. You're really the best person to... We've got about 50 minutes. So you're the one that best knows how many things you need to cover and what order we should cover them in. We may get to everything, we may not. So you may have to prioritize what we should cover. And it's really going to be based on how much difficulty you're having with it.
All right, let's do the text thing first.
Okay.
So I just need practice, like doing the California method and things like that, and then writing equations.
Can you give me a specific problem?
Well, the example she gave us was parentheses 2, comma 3, close parentheses, and then parentheses 4, comma 5, close parentheses, and that was one of the right equations of line if these fall on the line.
Let's do that. What's the standard general format for the equation of a line?
Y equals mx plus b.
What's the most important thing to figure out from that equation? M.
I don't know.
Slope. Slope is the key. What is slope equal to?
How much your line is increasing by?
A good way to remember it is rise over run. Because it has a certain ring to it and you'll never forget it. I mean, 5 years from now, you could remember slope as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that is the specific definition of slope. But as long as you remember rise over run, well, what is the rise? The rise is the change in the y-coordinate, which means it must have to be y sub 2 minus y sub 1, and the run is the change in the x-coordinate. So let's apply that to these 2 points. What's the slope going to be?
2 over 2.
So we have a slope of 1.
Wouldn't that be just the slope of x?
Yes. In other words, m is going to be 1. So, but we can't write the equation yet because we don't know what b is. Have you had point slope format yet?
I don't think so.
So you've only had slope intercept? What?
I don't know. She doesn't tell us the math terms, so I might have learned it, but I don't know.
Okay. Well, there's 2 ways to go from here. Probably the most direct way, without forcing you to learn another format, is to go ahead and let's solve for b. Well, I know my slope, so I know this much of the equation. And I don't need to write the 1. I just wrote it for effect. So I know this much, but I don't know what b is. Well, how can I solve for b? If I take one of my points, either one, and stick it in for x and y, I'm going to be able to solve for b.
Didn't you say like 2 plus 3 equals 0 or something like that?
Well, let's take the smaller numbers, because the math's always easier with smaller numbers. Let's plug that set of points. Remember, this is the x-coordinate, this is the y-coordinate. So if I plug those numbers in to this equation, what do I get? I get 3 is the y-coordinate equals x, which is 2, plus b. If I solve for b, what do I get?
You'd minus 2 from the right, and then you'd minus 2 from the left, and you get 1 equals b.
Okay. Now I have everything I need to write my equation of the line. What is it?
So it would be y equals 1 plus 1. Well, x plus 1.
That's it.
Okay.
And I could have used either point. I could have used this one here. It would have given me the same b. Notice it would have been 5 equals 4 plus b. So you can pick either point. Now, when I mentioned the point slope method, I'll just follow up on that briefly, and you tell me whether you've ever seen this or not.
Okay. I've never seen that. No.
Okay, well, we won't talk about that. It's a little faster way to come up with the equation of the line, but not a whole lot faster. Just as straightforward to solve for b. Okay? So there's a definite method with whenever they give you 2 points and they want the equation of the line. First thing, solve for slope. Second thing, pick one of those points, substitute it for y and x with the known slope, and then solve for b. That's it. Every time. Do exactly the same.
Okay.
Okay?
And I don't have another specific practice problem for this,
Okay.
but I know she said it'll be on her test. So do you have any?
Well, I can make up any 2 points. The truth of the matter is that no matter what 2 points you put, they make a straight line. So any 2 points, I can pick out of thin air and say, let's come up with the equation of that line. So I can do that.
Okay. I actually found another one.
Okay, it's better if you bring the problems. I really think it is because, you know, maybe I don't know the degree of difficulty you're working on and I give you one that's way too difficult, or vice versa, one that's easier than what you've been working on. So it's always going to be better if you bring the problems to these sessions.
Okay, so parentheses 10, comma 14, close parentheses, and then parentheses 30, comma 24, close parentheses.
Okay. I'll let you start out. How are we going to do this?
Okay, so you do y equals mx plus b, and then to find the slope, you do the rise over run, which is the change in y over the change in x. So the change in y is 10, and the change in x is 20. So that'd be 10 over 20, which is equal to 1 over 2.
Okay.
And then that would be the mx, and the y equals mx, so 1.5x. And then you still have to solve for b.
Okay.
So I'm confused on how you solve for b.
Pick one of the points. Either this one, I picked the smaller one because it's got smaller numbers, makes the math easier. Again, that's the x-coordinate, that's the y-coordinate. This equation has to allow that point to be on it. In other words, whatever equation we come up with, the points 10, 14 have to make it work.
Okay.
Okay?
Equals 1/2 10 plus b. And then half of 10 is 5. And, well, you could divide both sides by 5, I guess. Wait, no, you could minus 5, both sides. 5 from both sides, and then you get 9 equals b. So it's y equals 1/2 x plus b.
Plus 9. You meant to say that, right?
Oh, I didn't say that.
You said plus b. I knew you meant to say 9.
Oh, sorry.
Okay? Now, let me point out one other thing. That's perfect. That's exactly what you want to do on all of them. To do slope, it was y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can actually go the other way. You can do y sub 1 minus y sub 2 as long as you go the other way on the bottom also. Now, why would you want to go the other way? Well, let's say these were negative numbers. Negative 30 and negative 24. Now, is it easier to take negative 24 minus a 14? Or is it easier to take 14 minus a minus 24?
14 minus 24.
Yeah. So occasionally, depending on where the points are, it's going to make more sense to do this one. The only thing you have to remember is don't mix them up. Don't do y sub 2 minus y sub 1 and then x sub 1 minus x sub 2. You'll get the same slope, you'll just get the wrong sign on it.
Okay.
Okay? So either of these is okay.
Alright. I don't have any more practice problems for these. But
Okay.
can we do a couple to move on to the
Sure.
next, please? Okay.
Let me make here, let me change these numbers.
So, if y equals mx plus b, so to find the slope, you would do the rise over the run. So you would do 6 minus 6, which is 0.
6 minus a minus.
Oh, okay.
6 minus a minus 6.
Is 12 then?
Uh-huh.
Okay. And then you do 4 minus a minus of 2, which would be 6.
So your slope is 2. Okay.
And then you'd insert one of the x's back into the problem.
Which one are we going to insert?
4 and 6.
Yeah, not that they're smaller. These two are smaller, but they got positive signs on them. Avoid negative if you can. It just lessens the probability of having a mistake if we avoid negative numbers. So we're this far. So what am I going to plug in?
Then you could put the 4 in for the x and the 6 in for the y.
So it's b equal to?
8. Wait, no, it's 6 equals 8 plus b. So then you'd have to subtract. Hang on, I can't do this in my head. I need to write.
That's okay. No, go ahead. No, you should always probably have a pencil and paper with you, as well as your calculator.
Alright, so y equals 2x plus b and then 6 equals 2. So then 6 equals 8 plus b and then you minus 8 from both sides and you get negative 2 equals b.
Okay. So our equation,
It's y equals 2x minus 2.
okay. I have one more I want to give you because there are occasionally variations on this.
Okay.
It's the slope here.
I do a equals mx plus b, and then I do the rise over the run.
Okay.
So we do 6 minus 6, which is 0, and then 2 minus 4 is negative 2, so do 0 over negative 2.
Which is?
I don't know. Isn't it just 0?
Always. Any 0 divided by any number is 0. So our slope is 0. What does that tell me about our line?
I don't know.
It's horizontal.
Oh, wow.
It's horizontal. In other words, this is what a slope of 0 looks like.
Okay.
Okay? Vertical slopes have a slope of undefined or infinity, and I'll give you a problem like that in a minute. But so I have a slope of 0, Still has to fit this definition. It's just that m is 0. What's b?
So y equals 0x
Okay.
b.
Okay.
And then I'm going to put in the 2 and the 6.
Okay.
So 2,
No.
wait, no, 6 equals 2x plus b.
0 times 2 plus b.
Okay, and then
Look at my curve that I've drawn. What's the y-intercept?
6,
Okay. What's b?
6,
What's my equation?
y equals 0 plus 6.
Y equals 6. Anything multiplied by 0 is always 0, so it doesn't matter what x is, this is going to disappear. So y equals 6 is the equation. In other words, there is no x. Okay? So there's two special kinds of lines that don't follow our normal pattern. One is horizontal lines that are always y equals some number. If I want to draw a horizontal line through 3, that's y equals 3. And vertical lines. If I draw a vertical line, that's x equals 3. Now, what points would be on this line? Well, the x is, if I want to look at my vertical line here, clearly the x-coordinate is 3, right? Y-coordinate, well, hold on. X has to be 3, but y can be anything, because sometimes y is 10, sometimes it's 6. Notice that on my vertical line here, y is everything, or anything. Okay, but let's, assuming that these were the 2 points that they gave us on the test, how would we proceed to figure out that the answer was x equals 3? What's the slope?
The slope is y equals mx plus b.
No, the slope is the rise over the run.
It's just 3 over 0.
What's the rise? It's 4 over 0.
How do you get 4?
10 minus 6?
Oh, okay.
But it doesn't matter because you can't divide by 0. It's the golden rule of mathematics. Thou shalt not divide by 0 ever. It's actually equal to infinity. But an infinite slope is a vertical line. In other words, when I have this slope, it's called, I don't know what you call it in your class, but it's undefined, which is the same as infinity. The key is finding the moment you find a slope that is division by 0, you know it's a vertical line. That's the way you figure it out. And we know vertical lines are strictly x equals something. Well, clearly this goes through the point 3, so x equals 3, no matter what y is equal to.
Oh, on a test, I would just write undefined?
No. If they wanted the equation of the line that connects those 2 points, this is what you would write, x equals 3.
Okay.
You wouldn't write the slope, because they didn't ask for it. If they ask you for the slope, yes, you would say undefined. But if they ask you for the equation of that line, it's x equals 3, just like the equation of this horizontal line is y equals 6. Okay? So those are really the only 2 variations that could trip you up in terms of taking any 2 points and coming up with the equation of the line. We've basically covered all scenarios. So we can probably go on to other stuff if you want.
Yeah, okay, now let's do the box method, and I actually might have this problem.
Okay. Go ahead and give me the quadratic.
Okay, let me just look at my flow
Okay.
really quick. This is one I wanted.
Does your book go over the box or the diamond? Is it called the diamond method?
Yeah, that's what she calls it, but I just used the algebra connections book, and it doesn't explain how to do anything. It just has problems.
Because I have a problem. I don't know the diamond method, and I don't really know the California method. Now, that might seem strange, but the reason is that I don't work with very many Algebra 1 students. So I don't get students when they get taught those methods. I have my own method, as you found out last time, for factoring. Works pretty good. I don't have any problem showing you how to do my method, but I'd probably have to have you explain the box method at least once, and then I could help you with it. I could probably figure it out. If you can give me an example of how they use it on a given quadratic, then I can figure it out and I can show you what you're supposed to do.
Okay, sure. Yeah, I'll do that, because on the test I'm pretty sure you have to do this exact method.
Okay.
So, there is x squared minus 7x plus 10 equals 0.
See, that's x minus 5 times x minus 2. But that's by my method. So how would you do that in the box method? What should I draw over here? A box?
Yeah, you draw a box and you split it into 4 equal sections. And then you put, if you have it x squared, then you put that in the top left-hand corner. And then across from it, you put the constant.
Okay.
And then you draw 2 lines in the shape of an X, like on the left-hand side of your paper, so away from the box. No, not in the box, away from the box.
Like that?
No, like you draw an X underneath your box.
Ah. Like that?
Yeah.
Okay.
And then put, if you have an X with a variable in front of it, so the negative 7x, you put that in the bottom of the diamond of the X, basically. What it's called, a diamond.
Mm-hmm.
And then what you do is you take from your box how it's 10 and then x squared, you'd multiply those together and you get 10x squared, which you'd put on the top of the x. And then you have to figure out what times what equals 10x squared and what plus what equals negative 7x squared. And that's what you put in the x on the side. So I already put the problem in class, but it's just an example. So you'd put negative, well, it would be negative 5x and then negative 2x. So you'd put those on the empty sides of the x's.
You sure this shouldn't be 10x instead of 10x squared?
No, it's supposed to be 10x squared.
Okay.
So you have to take 10 and times the x squared.
Ah, okay, okay. So this multiplied by this is equal to that.
Yeah.
Okay.
And then you put the negative 5x squared in on the top of the box. And then
Where?
the negative on the top of the box, right across from the x squared.
Right, minus?
No, in the upper right of the box.
Ah. In the upper right quadrant, this one right here? And I should put minus 5x?
Yeah. And then in the lower left-hand side of that box, you put the negative 2x. And then you see what they have in common. So the x squared and the negative 2x, they both have in common an x. So you put that above the box on the left-hand side. And then the 10 and the negative 5x, they both have 5 in common.
They both have a factor of 5, okay.
Yeah, but it's actually a negative 5 because once you multiply it together, you get that.
Okay.
And then on the left-hand side of the box, the x squared and the negative 5x, they both have an x in common.
Okay.
And then right below that, you'd write negative 2 because that's what the negative 2x and 10 have in common.
So that gives me my answers.
Yeah.
Okay.
So that's what our test is going to be on.
Okay, and you sure we've done this exactly right?
Yeah. So what you do under the original equation, x squared minus 7x, put 2 parentheses, and then you write those, and I forgot to tell you to do that at the beginning.
That's okay. Okay. Now I know why I did it my own method, but that's all right.
Yeah.
No, seriously, I think the last time I checked this method out, I told myself, that's crazy. I'm going to do it my own method. But
Yeah, and I looked over your method before the study sheet, and before the study session, and I looked your method, but I just have to be able to show this one on the test. But I think it'd be handy to use your method to check my work.
okay. Let's try to do another one and see if I can figure out how to use this method over here.
Okay, I have other examples, but I've already done all the problems. But I can look for one in the book really quick.
Yeah, why don't you do that? Because obviously this method may work better when there's a coefficient in front of x. In other words, my method works fabulous when it's just x squared. I mean, there are no problems. You remember a couple of rules and that's it. My method becomes more trial and error if I put a number in front of there like that. And it might be that this California method works better. So if you want to see, I wouldn't mind seeing how this California method works when we have a number in front of the x squared. Because those are the hard ones to do. So if you have one like that, let's try one.
Okay. So there's 2x squared plus 2x minus 12 equals 0.
And you got that out of the book?
Yeah.
Okay. That doesn't really count because what's our first step here?
You would draw 2 parentheses after the equation.
Well, actually, there's a better first step.
Okay.
Factor out a 2 from everything.
Oh, yeah. So then that would be x squared plus x minus 6.
Now we have the easy case. I can do that in my head. X plus 3 times x minus 2.
Wait, how did you do that so fast? How did you get the x plus 3 and then the x minus 2?
Well, I know it's x and x. Whenever you start out with an x squared, it's x and x. Okay, once it's x and x, then it becomes relatively easy. My next step is to see what my signs are going to be. I want to know what this sign and this sign are. Well, that negative sign tells me that they have to be different from one another. One has to be positive, the other has to be negative. Then, after I get x plus and x minus, so this is my second step.
How do you know which side you want to put the plus on? Does it not matter?
Doesn't matter as long as the coefficients of the x's are the same.
Okay.
If one of them is 2x and the other is x, whole different story. That's the ones that become complicated and hard. And perhaps a problem like that, this method over here might work better. I don't really know. I'm luck. Can you find another quadratic that we know factors that has a number in front of the x squared and that you can't factor that number out from every term? Because I'd like to see this method in action with a quadratic that is not reducible to a quadratic that has no coefficient.
Okay, so I don't know if this is like the same for quad or, well, it says solve the equations below for x and then check your solution. So is that the same as doing the quadratic?
You mean on this problem here?
Well, no, there's this problem in my book that says solve the equations below for x and check your solutions, and then it has, so would that work?
Yeah. Okay, let's talk about this problem we just did here. Our solutions were x plus 3 times x minus 2, all that's equal to 0, which means x is equal to what? What are my solutions? In other words, these are the linear factors. Those are not the solutions. What is the solution to this equation?
When you do x plus 3 equals 0.
Yes, which means x equals minus 3. And then you would say x minus 2 equals 0, which means x equals 2. So when they say check your solutions, you need to go back to the original equation, this one, the one before we did anything to it, and plug in minus 3 and see if that equation works.
Oh, and if it doesn't, would it be 2?
Yes, well, you got to check both solutions. So let's check the first one. Is that still true?
Well, 2 times a negative 3 squared would be 2 times 9, and then plus, wait, no, that would be minus 6, and then it would be minus 12, and then equals 0, and then it would be 18 minus 6 minus 12 equals 0, so it would be 18, well, like, it would equal 8. It would equal
Is
0.
that true? That's all you need to know. Is that true?
Yes.
Okay, so that solution works. So we can put a box around it. That solution works. Now let's check the other solution. What's the other solution?
2, so it would be 2 times 2 squared plus 2 times 10. And then that would be 4 times 2, which is 8, plus 4 minus 12 equals 0, which is true.
So that one works also. Most of the time on quadratics, both solutions will work. The places, the types of equations where you end up with what they call extraneous solutions, where one of the solutions doesn't work, usually you find those, they'll have radical signs in them, they might have absolute value signs in them, or they might have logarithms in them. Any equation that has any of those things is very likely to have a solution that doesn't work. But straight quadratics like this, I would say every one you're going to do, both solutions are going to work. Okay? So that's what it means to check your solutions. Now, I'd still like to find a quadratic that has a coefficient other than 1 where we can use this method, because I'm still not positive I totally get this method, and I want to get it.
What about 3x squared?
Is this one out of your book?
No.
I don't want you to make it up because it may not factor. In other words, I could make one up. If we looked at this one here, there's a quadratic, but I don't know for sure that that factors nicely. And we could spend all day over on this California method here, and we wouldn't want to do it if it was with a quadratic that didn't factor.
All right.
I can kind of figure it out here. Hold on a second. I can come up with the right numbers here. So this would be, I'll do this my method. And
Can you method really quick, please?
I'm sorry, what?
Can you explain your method while you're doing it, please?
Yes. Well, first of all, I got to make up the right quadratic, and in order for me to do it, I have to test it with my method to see whether this might be a quadratic that factors or not. So, first of all, I'm going to break my 3x squared. That can only be 3x and x.
And then could you put the x and then the 3x on either side?
Yes, you can. I can
Okay,
switch.
That actually found one that will work really quick.
Oh, good. Give that to me.
Okay, so it's 3x squared plus 7x plus 2 equals 6.
All right. I was going to have to play around with that one just to see if it worked or not. Okay, now I can use my method real easily on this.
Okay.
So what goes here and here?
3x and then x.
Next step?
Then don't you look at the sign in front of 7x?
No, you look at the sign in front of the number, always the constant.
Okay. And
Okay.
so since it's a positive, couldn't they either be 2 negatives or a negative and a positive?
No, they can either be two negatives or two positives. They cannot be this, because a plus and a minus would always result in a negative number.
Oh, yeah, okay.
So they have to both be the same sign, and when they have to both be the same sign, you look to the sign of the middle term to see what it is. So they have to both be plus.
Okay.
Okay? Now, we want factors of 2. Well, there's not a whole lot of choice. I can either put a 2 there and a 1 there, or I can switch them. Notice that it does matter which way I go. If I put the 2 here and the 1 there, well, I get 2x and 3x. That only gives me 5x in the middle. That doesn't work. Well, there's only one other option to switch them around. Put the 1 there and the 2 there. Now I get plus 1x plus 6x. Add them together, that gives me plus 7x. That's the answer. And that's all I need to check is the middle term. Because I designed this whole thing based, I already know that's right, and I already know that's right. So the middle term is the only one I have to kind of play around with to get. Now, let's see if we can solve this one with your California method.
Okay. So first you would do box, and then you'd do a diamond. And you could even put the diamond a line down if you wanted, but, and then you would do the 3x squared in the top left-hand box, and then the 2 in the bottom right-hand box.
Hold on. In the other case, this was just x. Was it x squared?
I thought it was 3x squared in the problem I gave you.
No, in the first problem, x squared minus 7x plus 10, when we did that one.
Yeah.
What did I write in the upper left-hand box? Was it x squared or x?
It was x squared.
So this is 3x squared. Okay.
Yes. And then in the bottom right-hand one, you do 2.
Okay.
And then 7x would be in the bottom of the diamond.
Hold on. Okay.
And then you do 2 times 3x squared, which is 6x squared, which you put in the top of the diamond.
Okay.
And then you would say what plus what equals 7x, and then what times what equals 6x squared. So to get 7x, you could do 3 and 4, which wouldn't work with 6. Or you could do...
Okay, are we looking to fill in these two boxes or these two parts of the diamond next?
the diamond first.
Okay, so we want...
It takes me forever to fill these out because I can't, like, quickly get to what the answer is to put on the side.
So I'm looking for whatever I put here and here has to give me 7x?
Yeah, when you
Has to add to 7x. Okay.
When you multiply them, they have to give you 6x.
Ah, okay. So when I multiply them, they have to give me 6x squared, but when I add them, they got to give me 7x. Well, notice nothing does that except 6x and x. That does it. Okay.
Oh, you got
Huh?
okay. You got that really quickly.
Well, understand, I've been factoring for 5 years now, and I get a lot of practice at it. So I'm real practiced at finding factors of a number that add or subtract to another one. Okay, so now...
So you 6x squared at the top, right, and then x at the bottom left.
Why do I pick 6x squared to put up here? Ah, the product of those two.
Yeah.
What do you put down here?
And it's not 6x squared, it's just 6x.
Okay. Oh, you put this left number. Whatever's in the left part of the diamond you put up there?
No, you can put whatever's in the right of the diamond too. It doesn't really matter as long as you put them both in.
Okay, so the x goes there?
Yeah.
Okay.
You do 3 and x have in common an x, so you'd put that on top of...
So the x goes there.
And then...
The 2 goes there.
X and 2 is...
Ah, I get it. Now I get it.
Yeah.
Now I get it.
And
Okay.
put parentheses.
That is massively complicated. Wow. I can't believe that's the method they teach, but I guess it's better than my method in the sense that my method is, I call it trial and error. But notice that to come up with 6x and x, I had to do some trial and error.
Yeah.
In other words, my first guess would have been 3x and 2x, but that doesn't add to 7x. So I knew that wasn't correct. So I went to 6x and x. But there was a little bit of trial and error in there, but not a lot. So that's okay. Okay. I think I get it. But, more importantly, you taught it to me, so you clearly get it.
Okay. And then to check my work, I'm just going to can I say your method out loud and see if I get it?
Sure. You got
Okay,
it.
we can do it.
Okay. Let's do another problem.
2x squared minus 9x minus 35 equals 0.
Okay. This is a good one to do because I can't factor the 2 out.
So you put the parentheses in, and then you would do 2x and then an x, right?
Mm-hmm. I'll correct you if you're wrong. Don't worry.
Okay. And then you look at the negative sign in front of the 35 because that doesn't have an x in front of it.
Okay.
And since it's negative, you know that it has to be that both numbers have to be...
Both signs have to be different.
This one has to be a positive, right?
Yes, but in this case, that is different than this.
Yeah.
Because the x has a different coefficient. In other words, whatever number over here, one of them is going to be multiplied by the 2, the other one's going to multiply by the x. So it might matter. So I basically have to try 4 possibilities. I mean 2 possibilities. It can be plus minus or it can be minus plus. I write it like this because I'm going to experiment with factors of 35, putting them here and here, and just go through each one until I get minus 9 in the middle.
Okay, well, don't you start with the lowest numbers usually, so you could do 7 and 5?
I start with the numbers that are closest together. When I look at 35, factors are 7 and 5, and the only other ones are 35 and 1. 7 and 5 are closer together than 35 and 1, so I'm going to try 7 and 5 in my experimenting.
So you could put the 7 on the left and the 5 on the right, and you could do like plus 7, I guess, and negative 5.
Does that
So
work?
then if you do that, you could do 2x times x is 2x, and then plus
No,
7.
hold on, back up one.
Okay.
We know this term is correct based on this information.
Yeah, okay.
I don't have to check the 2x squared. Once I figure out the factors of 35 are 7 and 5, I don't have to check this number anymore. The number I need to get right is the one in the middle. So when I say, is this correct, do your two smiley faces connecting the inside and the outside.
Okay. So
And then
that
add
would
them
be
together.
Then negative 10x, which wouldn't work.
Doesn't work. Okay. Next step.
You could do a negative 7 and a positive 5.
Okay.
So then with your smiley faces, you would do 7 and then x, which is negative 7x, and then 2x, and then positive 5, which is going to be 10x, which doesn't work because that only gets you 3x.
Notice that it gave me exactly the same number, only the opposite sign. In other words, when we had the 7 up here and the 5 over here, we got negative 3x. So there's no real point in trying the negative 7 and the plus 5. It's going to give you the same number on the middle term, just a different sign. So we already figured out that 7 on the left and 5 on the right doesn't work.
Okay. Oh, but you can...
In other words, when I started out like that, I got minus 3x. The fact that this is a minus 3 tells me that this combination is not going to work whether I put the 7 down here and the 5 over here. That merely gives me plus 3x instead of minus 3x. So it eliminates some of the possibilities I don't need to consider. I don't need to consider putting the 7 down there and the 5 over there. But I do maybe need to consider putting the 5 on the left and the 7 on the right. Let's try that.
That would be 5x and then negative 14x, which would work.
Yes. Now, well, I got lucky there. We got it with the first try. But had I made the mistake of trying the 5 here and the 7 there as my first try,
Just 5x, and then it would be 14x.
notice that I get the same number, just the wrong sign.
Oh, okay. So you just obviously have to make the 5 a plus and the 7.
Exactly. And once I get this, I know the answer is to just change, move this 5 up to the plus and the 7 to the minus. And that will guarantee me that I get the same number with a different sign, and I want the negative sign. So it's not total trial. I mean, it's a lot of trial and error, but it's not, let's see, this is plus and this is minus. It's not like you have to try all combinations. You can eliminate a lot of them. In other words, you can go fairly fast once you get the hang of it.
Yeah.
Now, do you want to try that same problem with the California method? Or, we only have a couple of minutes left.
Okay.
What would you like to do? We got time for maybe one more problem of some kind.
Okay. Let's do another one of the line equation ones.
Okay. Do they always give you 2 points, or do sometimes they give you 1 point and a slope?
We've never had that.
Okay. So they're always giving you just 2 points.
Yes.
Now let me just make, you want to give me one, or you want me to make one up?
Did you make one up? I don't have one handy. Okay, so you'd follow the y equals mx plus b. I'm going
you'll also get a recording of the session by tomorrow morning, and you can look at it. You can go through it just like a YouTube video, so you can skip to the end, the last 3 minutes to see this. In other words, it's very efficient to watch these things. They're YouTube videos, so you can fast forward, reverse, pause, whatever.
Okay.
Okay? So just keep that in mind. I mean, I'm not suggesting you don't take notes. You can, but always know that anything we're covering, you'll be able to see.
Okay. It's just easier for me when I actually have it on my own paper. So.
Oh, for sure. Do it then.
Okay. So to find the slope, the difference between 5 and negative 7 is 12. And then it would be 12 over, no, because it's negative.
Just the only thing you got to make sure is you go the same way. In other words, it's a little dangerous doing what you just did, saying what the difference between them is, because on a number line, yeah, 5 is there, negative 7 is over there, there's 12 between it. But the sign is very important. Is it a plus 12 or a minus 12? Depends on which way you're going. It looks like you did 5 minus a minus 7. So you did y sub 1 minus y sub 2. That's perfectly fine. Just make sure you do the same thing on the x's.
Okay, so that would be 12. And then, wait, why would it be a negative 12 then? Okay, I'm confusing myself now.
Okay, because I did 5 minus a minus 7. That's equal to positive 12.
Oh, add them and get 12. Okay, I got it.
Uh-huh.
And so you do negative 3 minus 2 equals negative 5.
Okay, there you go. Okay, so that's your slope.
So that's slope.
Okay.
And then for B, you would insert one of the points back in.
Okay.
So it would be y equals, and I'll do the negative 3.
Okay.
So y equals
Not y.
12. Oh, okay. So 5 equals 12 over 5 times negative 3.
Okay. It's negative 12 over 5. In other words, that is a negative 12 over 5 times x, which is negative 3, plus
And
b.
then you have to figure out b.
Okay. So when I multiply those two together, I get 36 fifths positive,
And then 5.
which is 25 fifths. So if I subtract 36 fifths from both sides, I get minus 11 fifths equals b.
Okay, yes.
So my equation is what?
Y equals negative 12 over 5x plus negative 11 over 5.
Yeah, you don't need that plus, just minus 11 over 5.
Yeah.
So this is what I would want to write as an answer. Now, the only thing I want to just make sure you understand is that this is the same as this is the same as this.
Yes.
Okay. And this is the same as this.
Okay, yeah.
Okay? But a lot of people don't realize that it doesn't matter. If you only have one negative sign, it can be in the denominator, the numerator, or out in front. And it all means the same. Okay?
Okay.
All right. Well, thank you very much for teaching me the California method.
Yeah, thank you so
I'm
much.
not sure. I'm not sure I'll remember it, but I might. No, I don't know. That's pretty complicated. That is a complicated thing to remember. But it probably works. It probably works a little better when you're doing harder quadratics. I don't expect that you're going to have that many really hard quadratics to do. not in Algebra
Yeah.
1. Maybe when you get to Algebra 2 or Algebra 3 you will. But,
That's what I think.
well, if they want you to put that California method on there, then you got to know it. Whether I use it or not doesn't really matter. You know, if they say show your work and use the California method, you got to know it. But I think you do. And if they say just factor the quadratic, then use any method you want.
Yeah, okay.
Okay?
All right, thanks.
Okay, I will, like I said, I will process that file and I will send it to the email address. Let me make sure I have it here. Is this your mom, Sylvia?
Sylvia.schick@comcast.net.
Yeah. Is that where I should send the link? I need an email to send the link for this recording.
Let me ask my dad which one.
Okay. That I should use.
You could send it to mine.
Okay, what's yours? I'll write it.
It's lowercase I, capital capital L and then lowercase A-U-R-E-N, 07 at comcast.net.
07. You're too young to be an Elway fan. Where'd the 07
I don't
come
know. Those numbers.
from? Okay. These things take about 2 hours to process. There's a possibility I'll get it up there tonight, but for sure by tomorrow morning I'll have the file posted and I will send a link to this email telling you how to look at it, how to get it.
All right. Thank you so much.
You're welcome. Thank you. Good luck on your test.
Thank you.
All right. Have a good one. Bye-bye.